Tensorflow session. My name is Ayan Kenan. I'll be your host for today. So let's dive in. Our speaker for today is called James NANDWA, and he's such an incredible developer. He is he is a senior software engineer, and he's been a senior software engineer for the last 4 years. Apart from also working also as a software engineer, apart from also practicing as a software engineer for quite a long time. So today he has a project that he'd talk about. So I'd let him speak about the project itself, which is quite exciting. And he's going to talk about predicting plant disease in almost 5 different crops. So let's jump on it. And David Nando, you're welcome. You can take over.
Awesome. Thank you so much. Really quick, just let me know if you can hear me. But basically, yeah, I'm really excited to be here. I'm really excited that I get this opportunity, first of all, to showcase a project that I worked on last year as a passion project, which is quickly turning into something that would be very viable for the commercial space. And yeah, I'm really looking forward to breaking it down. But first off, as I mentioned, my name is actually David NANDWA, not James NANDWA, but I forgive her for that. And yeah, I've been a senior software engineer for 4 years now, working through a company named Kasai Tech with partners all over the world, in Australia, in the US, South Africa, and in Kenya as well. And most of what it involves is working with companies in the fintech, agri-tech, the e-com space, and also communities, in just trying to automate and smoothen, or rather make the processes more efficient by leveraging tech and software to do that. So yeah, like I said, I'm really excited to be here, really excited to talk through the product and how I built it, why I built it, what it involves. And yeah, without further ado, I'm gonna hop on my laptop and kick off. So just give me 1 second and we'll be able to get started. All right, so I just need Ayan or Marvin to confirm if they can see my screen, and I'll start from the very beginning. Please just give me a confirmation if you can see my screen.
Yes, I can see. I can see a screen now.
Awesome. And like the audio, you can hear me well?
Yes, I can hear you well.
Perfect. All right. So yeah, let's just go ahead and dive in. Before we
can see your screen.
I just want to give a small disclaimer. Like this session will involve a few technical topics. Sorry? Yeah, I was basically saying that the session will involve a few technical topics, but also very beginner-friendly stuff. And I will use as basic language as I can, as simple language as I can, to at least make it welcoming, not only for the person who's been using TensorFlow for 2, 3, 4, 5 years, but also who knows nothing about AI and machine learning. So yeah, I'm really looking forward to both introduce and have a conversation with you, TensorFlow, for a while. And now, without ado, I just want to give a quick overview of what we'll talk about. So we'll talk about the product, and I'll give you a demonstration. I'll show a screen video of the Sandbox app, why I built it. So then we'll move on to how it works, what it really takes to build a model and deploy it and use it in an app, and all of the facets of that. I'll also give a small code snippet on a really big thing that's not talked about a lot, and that's in the deployment process of using machine learning and artificial intelligence models and the training flow. And also I'll finish with how not to build an app with TensorFlow, because I feel that's important, just to help you not go through some of the things I went through because I didn't know better, or I didn't know how to approach this. So yeah, and also because the event is live, I'll try to basically maintain this energy just to give you guys a more physical feel. But I know the energy is there. I can feel it on the YouTube live, and I can feel it on Meets as well. So yeah, let's get started. So I'll play the videos, explain a bit on what's going on in both videos, and then we'll now talk about it in detail. So both videos are the application, using the application. The left one is a live detection demo. The second one is static demo with static images. So as you can see, the left one is performing a detection on an apple leaf through the video, and then it's given so it gives a prediction. In fact, let me pause this and talk through this one slower, because I know this would be important. You guys would want to focus in on this. So this is the Sandbox app. The production app, of course, the design is a bit different, and we've also added a bunch of features, but this is the core thing, and I want you to do it with a simpler app, so you just get a really, really concise overview. So like I mentioned before, I'm using my phone to videotape the leaf, and all it's doing, it's performed a prediction on the leaf, and it's noticed that it has no underlying diseases based on the data set and the model that I built off of it. So as you can see, it gives you information on, okay, what did it see, what did it notice, what should you do? And thereafter I kill the stream, and then I change the model. So now the next image I'm gonna bring would be a leaf that has a specific disease, which is the leaf spot disease in another crop, a different type of crop. And as you can see, when I scroll down, so without a shadow of a doubt, it's shown that it has powdery mildew disease, and all of this is automated. So all I have to do is just videotape the leaf, take off or upload an image of the leaf. And now, as you can see, the data that it's extracted is different. So it's telling this specific person, this farmer, this breeder, okay, this is what your crop has, this is what you should do. In fact, let me go back a bit and pause on the info. So here, it basically gets data from aggregated sources. These are sources that some of our partners, for example, like we've been able to get this data from them and then provide it to either the farmer, the breeder, or the user of this application. And this kind of data is what most people don't have readily available, that leads them to make bad decisions with their crops, because you have a situation where maybe I've noticed this has happened before, but what the crop could be suffering might be different. And that's where this app really sits in and tries to target the niche whereby you have a lot of people who maybe are, I would say, hobbyist farmers who don't really know a lot about farming, but they want to make better decisions with their crops. And really quickly, actually, let me tell you about the main reason why I even got into making this application. And that's because my mom was doing a small project with some of her friends. That's why I got the main inspiration from that. And so they had invested a lot into the farm, and it was on, I think, a 2.5 acre piece of land. But the problem is they had a sort of expert, but because they had to rely on him, someone like my mom or a colleague would not be able to go and, basically analyze the crops, make better decisions with the crops. And that's simply the niche that I'm targeting. It's most of the breeders, it's a lot of the hobbyist farmers. The app is meant for people like those who definitely need to make better decisions with their crops to increase their yields, but definitely they don't have the data, they don't have the time, they maybe don't have the resources to hire the experts. And that's where this kind of information would be so important. Analyze your crops. Very simply, all you need to do, point your phone at the crop, at the leaf, and have it give you really, really good and concise predictions and steps that you should take. So the other video is now basically just an image. So you take a photo of it, choose an image from a library. Maybe you're away and you want someone who's next to your plantation, your farm, to send you a photo so you can analyze it and tell them, okay, so this is what the crop had. Please do this and this and this. and will be able to now eradicate that specific disease. And yeah, so let me kick off. Sorry. Um, so yeah, I've been able to talk a little on how it works. I've started talking about how it works, but a bit in depth is basically the flow is a user selects a model of a specific crop. So at the moment, the data sets we have, the rich and quality data sets we have for maize, potatoes, tomatoes, cherries, grapes, and what else? What else? Let me just quickly even go through my own app to verify that I'm not telling you something that will be false. And so yeah, so those are and apple. Oh yeah, apple as well, and bell peppers and strawberries and peaches as well. So we targeted a lot of the fast moving crops that we can start with, which the data, gathering the data would be fairly easy and we'll be able to get quality data to build a model on. But I'll talk a little more about that in the future. But so basically it selects a model and the specific crop model is then loaded either from the cloud bucket, which it fetches it from, or local storage. Yeah, then there are things called weights and metadata, which I will talk about again in detail a bit later on, but those are then loaded. And once the weights are loaded and the metadata, the JSON file and the model file is loaded, it can begin now performing predictions on the image or the stream you've given it. So the loading of the model is really important, but initializing it as well is also really important. And the thing that you saw, it's routing the user to a different page. It does that once it already has a confident prediction. So it's analyzed enough data to say it can only, it has a high probability of being healthy or a high probability of having this specific disease. And that's where it's really, so the difference between it and a human making a deduction is we work with the specialists, we work with the data scientists to convert what would take a farmer from sending their crops to the organization, to the research facility, and then them telling them, okay, your crop suffered this over this period of time, and this is what you should do. So imagine if the decision was made 2 months later. By that time, they've already lost their yields. So that's where the prediction helps, but it's definitely not the final step. But also if the user doesn't have an internet connection, they can also load the model locally. That's why we also created the local models for that. And like I mentioned, yeah, the information is where they really now can make better decisions, and the information helps them to make these decisions, and now, which would now result in greater crop yields, but also intelligent farmers. You know, most of the ideas, or when you think about a farmer, you don't think about a data scientist, and that's the bridge we're trying to mitigate. Like, we're trying to say these breeders, these agriculturalists are not only in the crop business, but they're also in the data business, and that's making better decisions in the crops based on underlying data. And it's really that simple. Anyone can use the app, and that's really what you're trying to do. So really quickly, let me talk about data sets and the importance and why this is actually the most important aspect. So with machine learning, when it comes to building models for detection, whether it's object detection, like you can see here, what you are doing, which is the segmentation aspect of it, or even classification. Basically, you give a machine learning model pictures of dogs and you ask it to tell you what dog that is. With why it's so important to get quality data, why it's so important to get a lot of data, and by a lot I don't mean in the thousands, I just mean really good quality data, 50 to 30 images or 50 to 30 audio samples, is because the way you train a model is based on what you give it. Just the same way, the way you teach a child is based on what you tell and show the child. a child trained in a good school will perform better than a child trained in a bad school simply because you gave them better knowledge. And a machine learning model will make better decisions dependent on the data sets, the data that you provide it, whether it's an image model, whether it's an audio model. I mean, all of this banks on and relies on the fact that you're giving the model an easier time. And just to basically, how would I say, simplify this for the non-tech people here who are watching from YouTube. If you're just tuning in, or if you want to actually jump into this space, this is the most important aspect, and this is where you should really focus on. Because machine learning, when it comes to transfer learning, which is the department of machine learning that focuses on teaching a computer how to make decisions based on data, is it relies on you doing the hard work of getting really good data, and you uploading it to the computer and telling it, this is how an apple looks, this is how a pear looks, this is how an orange looks. You tell the computer that, you give it enough data, it's never gonna get it wrong, or it would get it wrong, like it would get wrong like 1% of the 99% of times you feed it that information. But it only does that because of the data that you give it, and that's why it's so important. And so, like, to really even simplify it even further, what it involves, like when you're trying to build a model, the steps, the process is basically you gather data. That could be audio samples. Maybe you want to create a text-to-speech application, or maybe for transfer learning, this would be a phrase. For example, you wanna discern the difference between saying hello and goodbye, so that, or on and off, maybe you want to automate your light, which would be a fun home DIY project, to turn on your light based on what you say. So you would now have a class 1, which would be hello, and another class which would be goodbye. Thereafter, you train the model. Training it is basically, this is the autopilot step, because in the training aspect, basically now you've given the computer all of the data, and it's now trained itself. And training is, I would say, a better word for that is the machine learning model now starts to learn the difference based on all of the images. So if you feed it 50 images of an apple and 50 images of an orange, what it would do, it would build a bias on how an apple looks and a bias on how an orange looks. And then when you feed it a random image that it's never seen, it would only make a prediction based on how it knows it looks, based on the data you gave it. But then after you've trained it, then when you're using Tensorflow or you're using Keras or you're using any tool, any AI or ML tool, it would export for you a model. Model is what you now use to test, or rather validate, that this thing can actually make real world decisions with stuff that is never seen. And so here I'm just going to basically now talk about the training aspect of it, and how, like, basically what's transfer learning on the server side and how to build reliable models. So on my right, you see what most people using TensorFlow would be using for model training. And this is TensorBoard. And why I said anyone can really get into machine learning is it's basically gathering data, feeding it into TensorFlow or TensorBoard in this case. And then all of these fancy graphs and everything is what data scientists use to make better decisions, or this is now where, for example, for this specific application, I would analyze the epoch accuracy. And that's basically just that it passed through the data once, and for 40 images, it got 20 right and 20 wrong. And then you refine the model by either increasing the data set or removing bad images or reducing the amount of images that you're analyzing and stuff like that. But aside from that, you need to be able to refine this model from the beginning, which is what I talked about earlier. And really good places, if you're an AI and ML enthusiast or you're already into this, hopefully this wouldn't be new news to you. So Kaggle is actually a resource that I started with before now I got into um, gathering my own data, building my own models. Kaggle has tons and tons of practice data. So even for plant diseases, by the way, so data which you can use to now really get your hands dirty with, and yeah, start to build simple models with even teachable machine, which I'll talk about in a bit. And there's also Samastos is actually a Kenyan. It's not a Kenyan company, but it's in Kenya now. It's in Nairobi. And what these guys do is they automate the process for you. So they gather the data and they build the models for you. So all you need to do is deploy. And this is really helpful, but is not helpful for the hobbyist. So this is now when you're serious. You're like, okay, I know how this stuff works. I want to partner with people who do this on a daily and really, really build a reliable model that I can use to perform actual predictions. And this is just a quick overview of just to differentiate. So with TensorFlow, you really have two main ways you would train production models, and that's either through TensorFlow or Keras. And there are a few upsides and downsides, but TensorFlow is really friendly because it's a low-level like API where it does a lot of the ugly stuff in the back and lets you worry about the good stuff. I'd say the friendly stuff. So you're just basically calling functions, and these functions then now perform all of the like linear regression, math, and we're not even gonna get into that. But so yeah, it basically does all of that really conk stuff for you in the back, and all you do is in 40 to 30 lines you can build, I mean, I would say world-changing models because there's a lot that you can do. You can predict people who are asthmatic based on their X-rays. You can predict this. I mean, there are some of my friends in the TensorFlow community, and I'll plug you guys onto the video. They run a company called Tambua Health, and these guys are able to now detect whether someone has a specific respiratory disease based on their breathing, because breathing, sorry, not their breathing, like using a stethoscope. And that's exactly what you can do with TensorFlow. You can build these really, really refined models with little to no of technicality. Of course, you still have to learn how to code, but it's much easier than with Keras. So Keras is, sorry, I even inverted it. Like, this is with Keras is where you have that low level the functionality and the sequentialness. And with TensorFlow is where you can really dig deep and yeah, customize everything and really nitpick on the model to make it much better for you. And I'm sorry I made that confusion, but yeah, so with Keras is more friendly than TensorFlow, but both allow you to do these really powerful things with them. Now, I just want to quickly talk about performance and efficiency when it comes to data sets and even building your models. So this is an actual code snippet from the code of the Angular application. It does a really simple function in the Sandbox app. And what it does, I'm just going to talk through the code and talk through why I did it. So the code here, as you can see, so it gets the file from the external URL of the model, the specific model. And then it converts, so, okay, I'll try and explain this very simply. So files need to be passed as a specific thing so that programming languages can understand. So they're passed as what is called a blob, but you have to convert that into a file in order to use it in TensorFlow. And that's really I mean, Eureka moment I had, because with TensorFlow, they want you to train and load the models strictly from the API. So when using both TensorFlow and Keras, you won't see a way to deconstruct and then reconstruct the data. So the approach you should take is, of course, I don't want to give it all away, so that you also have the chance to go and explore and really try and see how you yourself can do this. But I will tell you if you don't get anything from this, all my devs who are watching this, this would be the biggest plug that I'll be able to give, is there is a way for you to host your models on an external cloud bucket, which is outside of the TensorFlow or Keras APIs. There's a way for you to train them as well, externally using GCP and all, but you don't have to load them using the TensorFlow API directly. What you should do is, if you really have a robust model or you want one with refined control, meaning you're the one who dictates where it will be hosted. You want to load it asynchronously at any time, and you also want, but you still want the model to work. And that's where this is so performant. Like converting the files now, converting the blob objects into files and then using them in your app gives you the ability to load them asynchronously in the beginning, so you never have to load them again. Because one thing that you'll realize when you get into TensorFlow, or if you've used TensorFlow, the bigger the data set or the model gets, the slower or the less performant it is. Now, TensorFlow is very performant, but when you have models and data sets working with thousands of images, or working on the fly, or you want to deploy it to a device that doesn't have as much power, this is the niche. This is where you can really capitalize on control. So just remember, think of the model files that TensorFlow exports as blobs. Convert those to files, and it will give you all the control that you need. This, of course, is with a JSON file. For if you're a dev here, this is not the nitty-gritty part. The nitty-gritty part will be when you're working with the binary files. But same concept, and really the same. There's not much difference to it, if you just remember that one thing. And another thing I just want to encourage, you will fail in this. As I come to my conclusion, I have to let you all know that, especially when you get into TensorFlow and AI, machine learning, there will be a lot of ways to do it wrong. But when you do get it right, you will actually those wouldn't be failures, but they'll really be the opportunities you use to refine your model. In fact, fun fact about machine learning is it's actually a lot about failure and less about success. So the more your model fails, the more you know, okay, I need to refine, okay, I need to do this. So never, and let me just let you know, never ever push your first model into production if it makes a correct prediction. Because more often than not, if it works immediately, it's definitely not gonna work always. But if it fails a lot, then you know all of the things in production that won't happen. So that's really important. And I've taken, I'm about to wrap up. It's been about 30 minutes, so I want to leave time for Q&A. And please feel free to ask any questions. If I rush through something, you want me to even talk about it in more detail, I'm definitely open to do that. But the first thing I would say don't do is don't build models with varying data sets. And what that basically means is make sure if you're building an app and you want it to basically help you, I don't know, sort M&Ms. You know, the M&Ms have different colors. So what you shouldn't do is have blue M&Ms, 50 images of blue M&Ms and 100 of green. And why that's a problem is your final model will do something we call in machine learning overfitting. So it will have a greater bias to green because it's more confident in green because you gave it more to learn with. Just the same way that if you teach someone math for 5 hours and you teach them English for 1 hour, they will definitely know more about math than English, and it will make bad predictions and bad decisions in the future. Another thing, like I said before, I mentioned it a bit before, don't ignore the results. Train until the accuracy is really, really high, because what this gives you is reliability. You don't want your model to be in production if it can't work with varying and, maybe I would say blurry images if it's an image data set, or the audio is not clear if it's an audio one. You want it to be so good that even at its worst, it does really good. Like it actually gives information that is reliable. Also, don't try and reinvent the wheel. Like, please, please, please. Like, TensorFlow was built because before TensorFlow and all of these other AI and ML tools, it was really hard. Like, you had to be a mathematician or a data scientist to get into AI and ML. So don't try and reinvent the wheel. Use all of the tools at your disposal. Use Kaggle to practice. Use apps like Teachable Machine. Teachable Machine is also really, really good because it simplifies everything for you. Yeah, use everything, use your peers, use the community, which, like my fourth point mentions, reach out, as in there's so many people, especially in this Nairobi space in Kenya, who are, I mean, even much better than I am when it comes to AI and ML. And that's where you can really scale. You can really build really good models. Because when you come with an idea or you come with a not so refined model, it's much easier for you if you get help and someone tells you, okay, yeah, I went through that. This, as in, don't do this instead. So community is a huge part of the success of even TensorFlow, actually. Like, TensorFlow has about 1,800, I think it's even more now, but 1,800 contributors because they open sourced it. So TensorFlow 2.0 is only here because of the worldwide community. People like me, people like Marvin, Wayne, Irene, Ayan, who contribute to spaces like these. And what you're basically doing is you're plugging into not only a global community but a local one as well. And for me, simply, I believe that's the fastest way to scale and to move on. So yeah, I'm coming to a conclusion. These are helpful links. I'll actually I would wanted. These are really helpful links that I wanted. I don't know. Please, if you're watching this from YouTube, if you're watching this from Zoom or Meet, please screenshot this. If not, you'll be able to reach out on my handles, and I can send you all of the helpful links, or yeah, give you more information. And on these are some of this. So I'll talk about Teachable Machine for a bit. This is as in the bare minimum. If you don't even need to be a coder to use Teachable Machine, by the way, and to build actual machine learning models. Like, please, 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 if you don't do anything else and you're a beginner watching this, please go check out Teachable Machine. It's a really good tool to just get your feet wet with all of this. Coding Train is also a really good guy. I watch his tutorials a lot, and they really help to simplify and make this fun. So when you get into this also, on a light note, I have to mention that it won't always be fun, but if you have a passion for this, or a passion for new topics, a passion for, like really trying out daunting stuff, that would be fun. But the training and all wouldn't be the fun part, or I'd say even the gathering of the data would not be fun. But seeing your model in action, that should be your end goal. Seeing your model make predictions. So a little bit even on where we're at right now with the app, which is called the Ledger, is so we reached out to Caldro, and we're also looking at a lot of different partners in the agricultural space who, I mean, love the idea and are so willing to get onto it and to try it in production. And this, by the way, started as a passion project. So if you're watching this and you're even the getting into it is daunting, but don't be timid, don't be intimidated by it. Just get your hands dirty, and I assure you won't regret it. So yeah, without further ado, that would be the end. I definitely want to leave some time for questions. Seeing that time has gone, it's been about 30 minutes. So thank you for listening. Everyone who's listening on YouTube, everyone who's listening on Meet, on Zoom. I mean, it's been such an amazing opportunity just to talk about this product, to share a bit on this aspect of this app, and this aspect of development, like TensorFlow and machine learning. And I do hope, like, if it's one thing that you get from this, I hope you get at least one thing that you can carry and say, okay, I didn't know that, or wow, okay, that simplified what I thought was very complex, or I mean, yeah, that was really interesting to watch. Yeah, I really hope you got something. And now I want to shoot it back to Ayan. Ayan, you can take the lead, but I'm definitely open to questions. I hope you've been getting some questions that I can take. And please, yeah, feel free to ask anything that you'd want me to clarify or a question that came up while you were listening. Yeah, so shoot, and thank you so much. I want to thank Marvin and everyone for giving me this opportunity. So, Ian, back to you.
Okay, so thank you, David. I think we have learned quite a lot from you. I'd just like us to now address some of the questions that the public had. So let's dive into it. Okay, these are some of the questions that are being asked. Where did you get the data, and how long did it take you to research on this particular topic? How long did it take you to realize that this is the project you need to do?
No, that's a great question. That's a really great question. So first of all, let me tackle the first question. That's where did I get the data? So it actually took a little over a month to get quality data. But the plug I mentioned earlier, Kaggle, was really good to get the initial data set to perform a basic test to just see, okay, it's an idea. It started off as an idea. Can it really work? So I went on Kaggle, and more often than not, it will actually have the data set that you need to even just perform a test with. And most of the time, it's crazy, but the contributors, whether it's just like pro bono or whether it's them who are like actual professional data scientists, more often than not, the data sets are really, really good. But then now after for the production model, of course, I had to do it manually and a lot of the refining manually. And so me personally talking to organizations like CALRO, the Kenya Agricultural Learning and Research Organization. Yeah, that's it. It's a tough one, but yeah. So going to people like them, asking them if we can have access to the data in order to refine the model, because this is not only we don't want this to scale to a lot of countries before it's it's tested and it's proven here. So yeah, talking to most of it was talking to the people for the production model, was talking to the actual researchers and all. And to answer the second question, this is actually not the only project I was working on. And this is actually where I want to encourage a lot of software engineers, devs. If you're even in uni and you're doing computer science or computer engineering, listen, don't look down on those passion projects. And I know how tempting it is, because I'm speaking from experience, to start a project and like halfway you're just like, so you just stop. But I have to encourage you, like, more often than not, I would say the apps that we see or the apps that we use had to start somewhere. So it was a passion project before it was a commercial one. So treat every project as a commercial project, because you don't know which one will hit the fan and you don't know which one will hit the mark. So the more you shoot, I would say the bigger the chance you have to hit the mark. And when you do hit the mark, then don't stop there. Keep looking, keep digging, and you'll definitely bring change by continually trying. So yeah, this project was a passion project. I just wanted to start off a whim, but it's quickly turning into something that's promising and scalable because I started it and I finished it. So all of these passion projects that you have, if you're seeing a niche for it, don't start and stop halfway. Yeah, I think that answers the question. I hope I've answered it in its entirety.
Okay, thank you for that. Another question is, how accurate is your model in terms of percentage wise, and why do you think that it's accurate to that level?
Thank you for that question. That's a really good question, and also a topic that I didn't touch on as much as I wanted to in the talk. So the model at this time was trained with a data set of about 300 images per crop. So for example, with the maize leaf, which is a very commercial crop here, which is really widespread, we have about 4 diseases that we've built the model on and are constantly expanding as we get the data. And those 4 diseases, including the healthy leaf, were trained with a data set of about 300 images. So its accuracy is at about 86% there. And how we know that accuracy is true is one aspect that I forgot to talk on, which I'm going to mention now, is validation. When you're training your models, there has to be a stage and a place where you validate it, and you validate it with controlled and refined data. Controlled data is basically meaning you never want to validate a model in production. So you want to test your model, and then you have roughly 100 to 5 to 50 images that you'd feed it, and you have it now performing these predictions, proper predictions more often than not. So how I came and we came to 86% is because even with the validation data, more often than not, it was getting it right. And that's the most important. Another thing is with machine learning, it will never be 100, but if you're above 90, that's a really, really good space. Even 80, by the way, for people getting into ML or you've been in ML, you would know that at least above 80, you can start testing it in production and refining that higher and higher. So yeah, that's how I gathered, and that's how we validated it. And yeah, I'm confident at this stage, we're confident that it can work in production.
Okay, that was quite nice. I mean, to get to 86% accuracy, that is just unimaginable, and I feel like it needs a whole lot of training of the data to get to that point.
Yeah, for sure. No, yeah, that's the boring part, like I mentioned. The gathering would not be fun, but yeah, it's definitely the most important aspect of gathering.
Okay. So how did you choose your crops that you're using, or what aspect did you consider?
Okay, so like, in fact, that's a really good question as well. My initial thought was, okay, so I want this to scale, but I want it to be mainstream. But the question I asked myself first is, what data can I get quickly? So I reached out to, a few people on Kaggle who are actual data scientists who can get segmented data for me. Segmented is basically data that's been cleaned or refined so that the developer has an easier time to work with it. And so initially, these are not the crops I actually want. Not all of them are the crops that I wanted in the beginning, but these are the crops that the data was readily available to train on. So we're definitely looking at increasing the amount of crops that we manage, but this is solely dependent on the if we can get quality data and quality images to build a model on. So the crops that I am really targeting is a lot of the commercial crops here. And another important aspect of this model is it works on the crop itself. So if it's a tomato, it should work on a disease that's plaguing it. But it's really important for the growing stage where the leaves are the only thing visible and the diseases plague the leaf first. So if you can treat the disease there, then you can mitigate and improve the yield that you should bring. So I'm really looking forward to building it on maize, not maize, but what's this crop? I was thinking of, for example, the potato model that we have is not performing as good. Or watermelon also is something that we're looking into. Cassava is also a really huge one that I'm currently working with a few people on trying to get to build a really good data set so that the model that we deploy or you validate would make predictions. Because at the end of the day, the model should always be making accurate and reliable predictions.
Yes, for sure, for sure. I mean, each model needs to make a very accurate and a very accurate prediction that is So let me go into the questions that have been asked
Sure.
by some of the guys from YouTube. Someone is asking, are there many species of maize apple
Oh yeah.
that you considered training in your data set?
Yeah, so that's a really good question. So they are not different species, but then when building the data sets and when we're working with when we're gathering the data, the one thing that we looked at was, or rather, to refine the model, you shouldn't take the photos, the image. We shouldn't the images we got. We made sure that they are varying. So if maize leaf or an apple leaf basically has let's say it has a leaf spot disease, so we wouldn't take the image at one angle. This is how you refine the model. And I think I can go back to this to explain this better. I can go to the segmentation slide. So this is a cherry leaf, and it has esca disease. So we would take an image like this, but we'd also take an image from another angle of another leaf with the same disease, or even of it from a wider point of view, and then we'd now perform the object detection. So we've basically now segmented the place that it had the disease. And as you can see in this image, you have the leaf at the front, which is this one here, but you also have this one here, and it looks different from this one. So the importance is not, the species won't change, but to build a better model, you need to mix it up. Like if you're building a model for a chair, don't just take it from the front, like take it all around. And that's exactly what you did with this. Yeah.
Okay. Well, that's nice. I guess we can go to the next question,
Sure.
which is how did you learn TF?
Awesome. So I got into TensorFlow, I'd say in 2018, and I do not consider at all, I do not even consider myself like a data scientist and AI and ML engineer. Like I did this I started as a hobby, and how I learned is basically trial by error and a lot of YouTube University. So this is a shout out to everyone who's learning their coding on YouTube and by trying and failing. And that's the approach I took. In fact, building this model was a very uncharted territory for me because I didn't even know where to start. But if it's one thing that I know now is any person can learn anything they want, especially in this age, because the information is readily available. So you can do it as a hobby and build something that would be commercial solely because of how readily available the information is. And if you want, feel free to reach out and I can give you guys a few plugs which really helped me along the way. And yeah, just to make your work easier. But it's definitely like you can do this solely on like by learning on YouTube and reading a lot of ResearchGate papers on this topic because yeah, the information is so mainstream. But the one plug which I gave in the end that really helped as well is Teachable Machine. Like if you just want to get started, don't even want to do anything with your model, and you just want to see how AI and machine learning works, definitely go on the Teachable Machine site, which is by TensorFlow, it's by Google. And yeah, you can really get your feet dirty and basically see, like, okay, this is it. This is what transfer learning is all about. And thereafter now is when you can really go into the deep topics, like linear regression or different models and all of that stuff that, I mean, you don't need to get into it immediately. Yeah.
Okay. So what exactly did you use for your backend?
That's a really good question. So the backend is Node and Firebase for the application. And I chose Node and Firebase because I am a very much Google product evangelist. Like anything Google, I don't think I'd have anything bad to say about it. But that doesn't go to say that you don't have to use Google and Firebase. But I used it specifically because it would meet my needs for storing all of the models for the basically for the homepage where it's called asynchronously from the Firebase or the GCP bucket. And Node really was to handle the request. So, for example, the I run some functions to the Node backend. This is now okay. This is for all the devs, and probably a dev asking, but yeah. So I run some Firebase functions the Angular app uses to the Node backend. But most of the biggest reason I use Firebase and GCP is literally just to store the models and to be able to call them within the application. But yeah, basically that's it.
Okay, I think that's a really good combination actually. Firebase, Angular, and TensorFlow.
Yeah.
Nice. Why did you choose to have a different models for each crop?
Oh, I was wishing someone would ask that question. This is actually the sweet spot of this is the sweet spot of because so we were thinking of training on okay, we're thinking of training on all the crops and different crop types and building one model. But here's the issue with that, and you'll quickly realize that when you're trying to build models for things that are unique but also the same. And I say that because they're all crops, but if you've noticed with crops or fruits or whether you eat food, is all of these things are food or crops, but they have different leaves. They have different ways that they sprout. They also have different diseases. And so we segmented the crops and built models on all of the different crops because not only did it increase performance, but also the predictions were much more accurate because the model had less to go on. And like I mentioned before, these models are really they're not even big. It's like a few, like 2000 KB just around with a model that has, I would say, about 5 classes to 6 classes. And the diseases are not many, so that should be at the higher range. So you have some which only have 3 variations or 4 variations. So segmenting them will not only increase the performance, but also increase the accuracy without, basically the main accuracy. And it really, it was a big difference in the first model, which was basically built on all of the different crops at one go.
Okay. Okay, let's go to the next question. How easy or difficult was it to add the ML model into the app?
Hey, thank you. I don't know who's asking these questions, but I'm really loving them. So that was one of the hardest parts because, like I mentioned before, when you train a model with TensorBoard or Keras, there's a file that it will give you called a weight file, binary file. And like I said, with a binary file, it doesn't work like a JSON file where you can just extract the data. So you have to treat it as a blob, which is an object, which Angular can actually understand, and then convert it by just passing the data, the bytes, converting it into a file that's readable so that it would be able to make predictions. Like for example, for the live detection one, as you saw, it's making real-time predictions. So the model and the weights file are being used constantly. So you load it asynchronously, perform the conversion, and then now you can use it to predict on the video stream or the image stream. So the video stream or the image file. So this was actually like the key aspect in the whole thing. And I would say this was the eureka moment when it was like, it's not huge, but it definitely was hard. Didn't take a long time, but it was a very difficult aspect of the project in figuring out a way to load these models and make them usable for TensorFlow. Because if you've used TensorFlow or will start using it, on the documentation, on Stack Overflow, on the code labs, they'll always tell you to use, whether you're using TFJS or TensorFlow for Python, they'll tell you to load it with the inbuilt method. So creating your own custom method has its bugs, but when you're getting started, feel free to just use the inbuilt method. But the one thing it would not give you is the ability to call them asynchronously and when you want, and use multiple ones within the application. So yeah, it was a huge aspect and a difficult aspect of the application, but definitely the way to mitigate it gave us more control production model and in using multiple models within the application without it hunkering down on the performance too much. I hope that's answered the question good enough.
Yes, I think actually, I know you've answered the question. You've actually even expanded on the question. Another question is just on a general note. Okay, what sparked your interest in ML?
That's a really good question as well. I was just like any person who has never done any of this. Right now, where we are standing, basically everything has been invented that's been invented. For example, computers are so efficient, phones are so efficient. And if you look at all of the companies right now, AI and machine learning is the final frontier. And you at this age, there is not really much you can do to change the game with the processes that are already there when it comes to phones and computers. But since AI and machine learning is such an, like, there's not a lot that's been done in the space, it's very easy to turn a passion project into a world-changing one with little to no effort on your part because the initial effort will be enough. So with machine learning and AI, we can actually convert all of the information we have and teach our computers to make these decisions. So this is actually revolutionary and it's not even been tapped into all the spaces. So we're seeing it now in a lot of the chatbots that we have, and we're seeing it in the applications that also use it. Like, of course, if you use Instagram, the algorithm now, how it basically puts stuff on your explore page that it thinks you'd like. And these are very simple stuff. So you see, there's a lot of niches for this, and I saw the opportunity, and all I told myself is, it's either you fail or you actually do something that hasn't really been done a lot now. And it's a really good place to be in because you feel like you're in uncharted territory. I mean, almost like visiting a new country or, exploring. So it was mainly out of curiosity, but also out of excitement because, I mean, it's clear that AI and machine learning and augmented reality are definitely the way the world is moving now. So it's just about trying to beat to the same rhythm. Hello, Ayan, are you there? And I hope I've answered the question elaborately.
Okay. Yes, you have. Another question is just a brief one. What advice would you give to people who are currently working on ML?
Oh, that's a really good question. I think I would have I'd say three pieces of advice. Number one would be your data set is everything, and I can't stress it enough. Like the data set you use to build your application. Sorry about that. The data set used to build your application is everything. So focus on getting quality data, and everything else will not be easy, but it will be much easier than it would have been with bad quality data. Number two is reach out to community. Like um, most people who see Facebook only see Mark Zuckerberg, but there are so many engineers he also worked with to build the app that we have now. So definitely reach out to community. Community is so important, especially when you're working on something that you're not familiar with, or even if you've been in this space, community is the only way to drive and bring real change because more people means more advice. More people means more refinement. More people means a better quality end product. So reach out to community. And lastly, don't be too hard on yourself. Be sure that you'll fail, and don't even be afraid of machine learning, TensorFlow not being a thing, because there could be another aspect of this whole space that could be a thing. So don't be afraid to try, fail, try other stuff, and really get your hands dirty. Those are the only three pieces of advice I'd give. And yeah, don't be too hard on yourself. No one's an expert. Even the experts aren't experts. So being a beginner is actually a better place than thinking you're an expert. And yeah, basically.
Just as we wrap up this session, what is your parting shot for this particular amazing session we've had?
Oh, my parting shot would be, first of all, I thank you so much to Marvin and the team for giving me this opportunity. It's been amazing. Even though I can't see everyone, it's a different type of event. I can feel the energy. I can feel that I believe that people have actually gotten something from this, even one thing, that you've done something. And I'm really looking forward to, being more active in the community, because I strongly believe the only way to drive real change is through community, and we should be focused more on empowering everyone else so that we can bring the change faster. And I just want to say, yeah, like, many thank you. And yeah, I'm really looking forward to seeing the fruits of this talk in people doing amazing stuff together and with the TensorFlow community. And please don't hesitate to reach out after this on my handles. You can ask me questions. I've seen on my phone, I'm seeing a few people have followed me. So thank you for increasing the follower count a little on my socials and all. And yeah, no, it was an amazing time. I had an amazing time through this talk. And I really hope that one or two people have gotten something that they can say, I'm glad I joined and hopped onto this virtual dev summit. Yeah, thank you so much.
Okay, so thank you, David NANDWA. I think we've had such an amazing session, and even with we look forward to seeing your future work regarding this particular project.
Yeah,
it has been such an amazing time having you on board.
Thank you so much, man.
I'd just like to sensitize on the last thing one thing you've mentioned, and just rephrase it in terms of inspired to empower. Yes, that's what I always tell people around me. Always inspired to empower, and through such communities and such events is when we get to all learn from other people within the community, share experience, learn, and connect.
Yeah, no, I strongly believe in that, and I hope people now plug into the GDG community, the TensorFlow community here in Nairobi and Kenya as well. So yeah, community for the win.
Thank you. So community for the win. Thank you guys for watching. Thank you to the attendees, even for the guys who are watching from YouTube. Catch us on Wednesday, Saturday, and next Monday on the same channel, same time. On Saturday, especially, we're going to be having machine learning, GDE. GDE means Google Developer Expert. So catch us there, come learn, share, and let's experience this fun session together. Thank you so much for attending this session. And that's all from me. And I also wish to thank Ngesa and the team, the Cloud Study Jam team, which has actually organized the whole session. Technically, it's under GDG. Thank you to the GDG community for organizing this. And we hope to catch you guys next time, same time, on Wednesday, Saturday, and Monday. Thank you guys once more.